March 2020. As the corona crisis unfolds, in a small group of friends I have hunkered down at our property. Being in one of the epicenters of the virus, yet protected at our walled-off garden and workshop, we can largely ignore the craziness of the world outside, being prepared to stay here for some time to come. When I first saw that the normal way of life would soon be suspended, with almost all businesses shutting down, I took some extra trips to various scrapyards, filming in advance. Here is some of what I found. So we're back, searching through piles of trash for old tools and useful items to be repaired, reused and repurposed. On top of my usual search for tools, parts and materials, this time I'm also especially looking for parts for a coal-fired forge that we are also going to build in this episode. So let's see what we can find here. Among other things, I'm looking for a powerful blower or fan for that forge I want to build. Well, this is a powerful fan, alright. This must be at least 1.5 meters in diameter, or about as tall as a small person. Well, maybe a little too big for what I had in mind. This here looks more interesting though. A motor coupled to a blower and some other pump. I'm taking this with me. It could be well suited for the forge. That thing up there seems to be an old plowshare. Interesting. But luckily we don't need those anymore. Yet. And what do we have here? That's a small, but actually pretty valuable part. What is it? Well, we'll talk about that in just a minute. What do we have here? Again, massive parts. Looks like the giant version of one of these here. A rusty old hand vise of sorts. That one I'll keep. And this tool here. And this old wrench as well. I also need a workbench surface for that forge, and that's why I'm taking this steel plate here with me as well. And last but not least, we also need a sort of fire bowl for the forge, and we're going to use a brake drum for that. And that one in the middle here is just what we need. Okay, I'd say let's leave this place then for today, restore those old tools and build that forge. And as usual, I start with something really easy and then progress to the much harder stuff. These two tools here require a little more than a little sanding and some oil. It is beyond me why anyone would think that this wrench belongs to the trash. The company name is Reitco, another manufacturer from the city of Remscheid, which just keeps appearing in my videos. Reitco was later bought by Metabo and seems to no longer exist as an independent company. What about this part though? It just looks like a hunk of steel, right? So how could it be valuable? Well, in German this is called Stiftamboss. Bottom anvil is the English word as far as I know. It is a small anvil that is inserted into support like this or this one here. And these little anvils are actually pretty expensive and rare. What about the other small tools we found though? Well, for one, there was this small vise-like tool. And then there is this special set of keys or wrenches. I want to put them in citric acid in order to remove rust on the surface, but they are so dirty that I decided to put them in the ultrasonic cleaner first and only now set up a bath of citric acid. After that procedure is through, it still is often necessary to remove the remains of the rust and dirt manually. It really rarely works out that the acid does all the work. But what are these tools? This small clamp that looks like a vise is called Pfeilkloben in German, and that means as much as filing clamp. It's a handheld clamp for filing work. And what about this part? Well, it's a set of triangular keys. And believe it or not, a new set of those is around 90 euros. Well, but enough of this. Let's go to do something much more challenging. I will now build a new coal-fired forge with parts I found at the scrapyards. Until recently I have been using my old forge. It still works, but I would like to have one with enough capacity to heat up larger workpieces. A more powerful forge is also needed in order to use the foundry attachment that I built in episode 9 of the series to its full potential. All older episodes can be found in the video description below, by the way. We start with this pneumatic assembly. Let's take a closer look at it. It has a 750 watt 3-phase induction motor, but not rated for 400 volts 3-phase as is usual here in Germany, but for 230 volts. We will probably run this in conjunction with a capacitor on 230 volt single-phase AC. This fan here appears to be a powerful 4-stage design. Like the motor, it was made by the Japanese manufacturer Sanyo in 1990, now owned by Panasonic. Sanyo got into huge financial trouble after their semiconductor plant was destroyed by an earthquake in 2004. This is a small vacuum pump manufactured by the Orion Dry Pump Corporation of Japan. I contacted them in order to find a datasheet. Orion told me that this pump was specifically built for a customer though, but that they still sell a model with similar specs, and they were so friendly as to send me this datasheet. The black box here appears to be a filter. The entire assembly is pretty dusty and dirty. This white dirt, or maybe dry rot, has collected around the belts. I remove the belts and put them in the ultrasonic cleaner. The yellow coloring of the metal sheets used here comes from a process called chromate conversion coating, a technique that was, at least according to my observations, used more often by the Japanese companies than here in Germany. For example, look inside any older given Japanese audio amplifier or receiver, and it's likely that you will find that yellow coating. Unfortunately, that process involves hexavalent chromium, which is toxic and can cause cancer. I will have to take precautions when I want to grind or weld this material. I take everything apart, looking for obvious damages, and I clean the entire unit and put it back together. 4 wires come from inside the motor. The black, white, and red wires are connections for the 3 phases. The green wire is the protective earth. In order to run the motor on 230 volts single phase, a large capacitor will be required. This compressor pump that I removed from a compressor in an earlier episode has a 40 microfarads motor capacitor that we can connect temporarily for a test. Since the motor and blower seem to work just fine, let's head on to build that new coal-fired forge using this powerful motor and blower assembly. This is the big old brake drum that I found on one of the scrapyards. It will act as a fire bowl holding the coal and the workpiece. It is made from cast, which is much better suited for this job than the mild steel I usually use for welding. It should be very resistant to the heat and heat-related stress in the forge. But I need to remove the bearing in the middle and the cast inner ring holding that bearing. In order to do that, I cut a number of slits into that ring with a cutting wheel. Relieved of tension, the bearing can just be punched out now. While the cast is very heat and fire resistant, it is also quite brittle, and after cutting those slits, chunks of it can just be broken off with a hammer. More slits are cut and more pieces broken off. The grinder is used to get an even surface here. The drum is now much closer to the form of a bowl. Before I proceed to build an attachment that will connect drum and blower, a heavy steel plate is needed in order to hold it in place. But first, all the paint needs to be removed. What happens here in seconds took me at least half an hour in reality. Now the outlines of the drum are drawn onto the plate, and I use a punch to mark a circle that might have better visibility for me when I operate the cutting torch on this shiny surface. The oxyacetylene torch is used to first preheat, then cut out the circle. I'm still not that good at cutting with the torch, but I will get there eventually. Now the grinder is used to smoothen the edges of this hole until the drum fits in smoothly. Stock is cut and TIG welded on the welding table in order to form a frame that will hold the plate, carrying the fire bowl and blower assembly. A lot of work is often required in making a part that will connect 2 or more parts that were never meant to be connected. This time I need to make an attachment that will connect the bottom of the brake drum with that blower. An approximately circular piece of steel is cut out, then ground into a round shape with a bench grinder. After drilling 5 holes into the steel plate, it is bolted onto the drum. Now vent holes are drilled through the steel and cast material. This is where the air will flow from the blower to the coal above. The air must be led from a rather tight circular tube to the widely spread vent holes in the drum. This requires an adapter piece of sorts that will connect to both parts. Because of the 5 bolts and the fact that I had some flat steel cutoffs lying around, I decided to cut and weld them into the shape of a pentagon. After the correct bolts had arrived here, 5 of them were used to connect the 2 parts tightly together. Now the motor and blower assembly is loosely placed into the bare frame of the forge. A steel tube is cut to length using the old pipe vise once again, another tool from the scrapyard. And in order to connect that tube to the brake drum, our leftover steel cutout will be used. A pentagonal shape is drawn onto it. In its center, a hole for the tube will be cut. Since acetylene and oxygen are expensive, this time I will use a more primitive method to cut a hole into this plate. Smaller holes are drilled into it. A hammer and file are used to do the rest. And then the angle grinder with a cutoff wheel is used to cut out the pentagonal shape. All this could be done with a plasma cutter, or better yet with a CNC plasma cutter. And I want to build one of those in the near future. But it's also good to know that you can make almost everything with a drill press and an angle grinder, as long as tolerances aren't really an issue. The bottom plate is welded to the pentagon. And now the tube needs to be adjusted to the right angle to connect blower and bowl, before it is TIG welded in place as well. A simple aluminium strip is modified in order to connect blower and tube. And then the inlet tube of the blower is ground off with some sandpaper. I almost always wear a dust mask around the shop these days, but in this case it seems more advisable than ever, because of the issue with the hexavalent chromium I mentioned before. The inlet will be extended with a steel pipe. You'll understand why in just a minute. On the top side, the drum is fastened to the steel plate by first welding 3 steel angle pieces to the plate, then heating them up with a TIG torch and hammering them down, then wire wheeling them off. In order to protect the motor and other electronics from hot coal or metal flying around, the steel frame is closed by riveting aluminium sheets to at least 3 of the 4 sides. The front side might later get a door of some kind. In the final steps, the hole in the steel plate is closed by welding a piece of flat stock into it, then grinding it down. The air intake has already been extended, and this side of the frame is also closed with an aluminium sheet. In a final step, a new 100 microfarad motor capacitor and an off switch are added. Also, don't forget the protective earth. The new inlet has a slit cut into it that, in conjunction with a simple piece of aluminium, provides a primitive mode of limiting the airflow. And now it looks like it's time for the real deal. A small wood fire is set up inside the drum, and we wait a few minutes. All the while, the sun is setting and it is getting dark outside. Now I will activate the blower and add blacksmith coal to the fire. Exciting, fun, and probably dangerous. It is obvious that the blower is still a little too powerful and maybe needs to be adjusted with an electronic speed controller. But on the other hand, it is so strong that it can apply a lot of heat in a very short amount of time. An axe head is inserted into the coal pile. And in no time it is ready to be forged. And rest assured that you will see this forge again the next time a project requires forging or heating of metals. I will also build a speed controller for it. So, as always, I hope that you like this video and that you like the Repair-A-Thons. And if that's the case, then please give this video a like. That way you can show me that you like it and I can go full steam ahead with the production of new videos. And if you want to support this channel actively, you can visit my Patreon under patreon.com/tpai and become a supporter. Or you can also find a donation link in the video description below this video. See you soon, guys.